चलें भाई बच्चों, हमारे पास ये क्वेश्चन यहाँ मौजूद है. How can we solve this? Just let's check this one. First of all, they are asking for many compounds, the enthalpy change of formation cannot be calculated directly. We know that an indirect method based on enthalpy change of combustion can be used. The enthalpy change of combustion can be found by calorimetry experiment in which the heat given off during combustion is used to heat a known mass of water and the temperature change recorded. We know that we did this, right? And then they are saying explain the meaning of the term standard enthalpy change of combustion. It is of 3 marks. It is to be noted. It's very important to know. 3 marks, right? So you can say that enthalpy change, you can say that enthalpy change when 1 mole of a substance, when 1 mole of a substance is combust, right? When 1 mole of a substance burns, ये combust, आप लिख सकते हैं burns in excess oxygen, right? Enthalpy change when 1 mole of a substance burn in excess oxygen completely under standard conditions. So bacho, you need to write this to get 3 marks, and all 3 important points over here is 1 mole and in excess oxygen and under standard conditions. So these 3 marking scheme words would give you 3 marks for that. All right, and then they are asking to write the equation for the complete combustion of ethanol. So we can write ethanol is C2H5OH, and when it completely combusts in the presence of oxygen, it definitely produces carbon dioxide and water because we just have these 2 elements in the ethanol, right? And we know that we have 2 carbons over here, so definitely 2 carbon dioxide would be produced, 6 hydrogens over there, so it would be 3 water molecules, and now it would be 3 and 4, 7 oxygens over here, 1 already in alcohol, and then 6 remains to balance. It is 3 to the 6. Now this is balanced chemical equation for the combustion of ethanol. Okay. Then after that, it is saying that in an experiment to determine enthalpy change of combustion, ethanol 0.23 grams of ethanol was burned, and the heat given off to raise the temperature of 100 grams of water by 16.3 degrees centigrade. Calculate the heat energy, or you can say that heat energy change Q during combustion of 0.23 grams of ethanol. We know that the formula for heat energy is Q is equals to MC delta T, right? So the mass of water right now is 100 grams. The C is constant 4.18, and the delta T is already given to us, which is 16.3. और हमें already बता दिया कि इतना बढ़ रहा है. ठीक है बच्चों, तो what is the right answer of Q that we have in this? Let me calculate. It would be 100 into 4.18 into 16.3. So it gives us 6813.4 joules, right bachcho? And we know that whenever we are going to find out the enthalpy change, so we need to know energy in kilojoules. We need to know energy in kilojoules or the number of moles of the substance which is going to be burned. So over here we have ethanol, which is 0.23 grams. So we know that it is moles is equals to mass over mR. So 0.23 grams over 46, the mR of ethanol. So it would be the number of moles. Let me check the number of moles. It is 0.23 over 46. So these are 0.005, right? The number of moles. And if you divide the energy by 1000, so it will give you 6.8134 over 0.005. So it is 6.8134 divided by 0.005. It gave us what, bacho? 1362. 1362.68. 1362.68. बच्चों ये आंसर आ रहा है सबका?
Yes, sir.
Good, very good. Then in the last part of this B, part, they're saying suggest two reasons why the value of the enthalpy change of the combustion of ethanol determined by a simple laboratory calorimeter experiment is likely to be lower than the true value. Definitely, there would be some heat losses. You can say that energy losses to the surrounding, or you can say that incomplete combustion of ethanol. It can also be happen in complete combustion, or ethanol is volatile liquid, so it can even evaporated. So you can say that ethanol evaporated. Ethanol can be evaporated as well. So any two reason over here you can write. Right, Bacho? Is that clear?
Yes, sir. Sir, we have to mention a negative sign for the enthalpy change, right?
Yes, you need to mention the negative sign over there because it is combustion. So you can write over here negative as well. Over here as well, right? If you want to, otherwise it's fine if you are not writing with Q, right? You just write the enthalpy change negative because this is the enthalpy change of combustion, and all the time combustion is going to be negative. And also one more thing you need to keep remember that the temperature over here is going to be raised, right? So whenever the temperature is going to be raised, it is exothermic reaction, right, Bacho?
Yes, sir.
Chale, the next part would be 2 ka C. Then let's see what this C part is saying to us. So this is the part C. So if you talk about part C, so just look at over here. There is saying that we have the table gives some enthalpy changes for combustion values, the combustion of carbon, the combustion of hydrogen, the combustion of propanol, right? They are saying construct a labile energy cycle to show how these values could be used to calculate the enthalpy change of formation of this. This is formation, right? So how can we form this cycle? So we need to know that whenever carbon is going to be combusted, it is going to produce carbon dioxide, and definitely 3 carbons are going to be combusted, so there are 3 carbon dioxide to be produced. Then whenever the hydrogen is going to be combusted, it is going to produce water molecule, and right now we have 4 hydrogen molecules, so definitely 4 water molecules to be formed. And then when this is going to be combust, then carbon dioxide and water to be produced. This is what the cycle you need to draw. Then they are saying calculate the enthalpy change for the formation of propanol. So we know that when the carbon is going to be combust, it is 393.5 energy which is releasing, and right now we have 3 molecules, so into 3. And then when water molecule is going to be combusted, or hydrogen gas is going to be combusted and water molecule is going to be formed, it is 285.8 energy which is released, and right now we have 4 molecules, so into 4. And you can see this oxygen is itself a molecule which is used to combust the fuels, but it is not going to be used as a fuel, so हम उसकी बात नहीं कर रहे हैं. But propanol जब आपके पास combust होता है, तो it would produce 2021 kilojoules energy. Now we know this, that here we have these 2 arrows all the time in combustion, that in a row, and they are opposite to be added, right? So you can solve in this way, that it will be delta heat of formation of propanol, and it is 2021 is equals to 3 into 393.5, and then it should be plus into 285.8 into 4, right? So let's check कि क्या आंसर देता है आपके पास. 393.5 into 3, it is negative 1180.5, and it is also negative, so it would be 285.8 into 4, it gives us 1143.2. So when we add these 2 values, this will be 23.7 in negative, and this is negative, so when it comes over here it should be positive, so it should be 2021. So when you subtract 2021 from this, so it would give you 302.7 in negative. Is that right, बच्चों? आप सबका यही आंसर आ रहा है?
Yes, sir.
Yes, sir.
Any problem to any one of you? All clear? चलें, तो अब हम चलते हैं नेक्स्ट क्वेश्चन की तरफ. Okay, so the next question is, let's check कि भाई वो कौन सा क्वेश्चन हो सकता. तो आपके पास इस तरह का क्वेश्चन हो तो आप इसको किस तरह सॉल्व करेंगे. लेट्स सी. अगर आपके पास एंथैल्पी चेंज का सवाल आए और आपने इन सबको यूज करना हो डेटा बुकलेट से, तो बड़ा मजे का सवाल होता है ये. मेरे हिसाब से तो इसमें आपके फुल मार्क्स आने चाहिए. और लेट्स सी कि ये 3 मार्क्स हम कैसे गेन कर सकते हैं. तो ओवर हियर द फॉर्मूला इज लाइक दिस ऑफ इथेन, राइट. वी हैव 6 bonds of like carbon and hydrogen, right? 1 2 3 4 5 6 bonds and 1 carbon to carbon bond, right? And also we have 1 chlorine to chlorine bond. And then on the other hand, just look at over here, we have 5 bonds of carbon and hydrogen, 5 bonds of carbon and hydrogen, and 1 carbon to carbon bond, 1 carbon to chlorine bond, and 1 hydrogen to chlorine bond. अच्छा देखिए बच्चों, इस तरह आसानी के लिए आप क्या कर सकते हैं, जब यहाँ पर आपके पास कार्बन टू हाइड्रोजन के 5 बॉन्ड ऑलरेडी हैं, तो आप यहाँ पर 6 टाइम करके वहां 5 टाइम करके आप इस तरह ना करें. आसानी के लिए क्या करें, आप 6 की जगह यहाँ पर आप 1 यूज कर लें और यहाँ 5 के 5 यूज ना करें. तो 5 से 5 यहीं कट कर देना, पहले ही कट कर देते हैं. ठीक है, सेम एज इट इज कार्बन टू कार्बन यहाँ पर भी है, कार्बन टू कार्बन यहाँ पर भी है, तो इसको भी कट कर देते हैं. तो बचा क्या हमारे पास, कार्बन और हाइड्रोजन का एक बॉन्ड 410 और क्लोरीन टू क्लोरीन का एक बॉन्ड इट इज 242. तो इसका आंसर कितना आएगा आपके पास, इट शुड बी 652, राइट बच्चों. इसी तरह यहाँ पर कार्बन और क्लोरीन की जो बॉन्ड एनर्जी थी वो थी 340 और इसकी थी 431. सो इट वुड बी समवेयर 7 and 7 1, right बच्चों. Then I told you to subtract product from reactant, so it would be 771 minus 652 and it would be I think 119, right बच्चों. ऐसी आया आपके पास.
Yes.
तो ये आसान तरीका है. दूसरा ये कि you can see this is actually alkane and reacting with halogen to form halogenoalkane and HCl, and we know that this is free radical substitution reaction and we use UV light in this, right? Or you can even say that sunlight. ठीक है. और दूसरा ये कि देखिए ये बहुत इंपॉर्टेंट हो सकता है आपके पास 5 मार्क्स के लिए. तो वो कह रहा है कि पूरा मैकेनिज्म बना के दिखाओ, क्योंकि आप ऑलरेडी फ्री रेडिकल सब्स्टिट्यूशन रिएक्शन कर चुके हो, तो मैं आपको करके दिखा देता हूँ. ये सबसे पहले हम क्या करेंगे, इनिशिएशन करेंगे. एंड वी नो दैट इनिशिएशन में आपके पास यहाँ क्लोरीन मौजूद है, तो क्लोरीन की इनिशिएशन करेंगे. इन द प्रेजेंस ऑफ यूवी लाइट दिस क्लोरीन मॉलिक्यूल इज गोइंग टू ब्रेक डाउन homolytically and it is going to produce 2 free radicals. And then propagation. अब सारी की सारी प्रोपेगेशन आपने नहीं करनी है, प्रोपेगेशन सिर्फ आपने तब तक करनी है जब तक आपके पास ये मॉलिक्यूल नहीं बन जाता. सो वी नो दैट C2H6 है, उसके ऊपर क्लोरीन रेडिकल अटैक करेगा and it will form C2H5 radical along with HCl molecule, and then this C2H5 radical is going to attack on chlorine molecule and it would form C2H5Cl. बस यहीं तक करना है हमें, इससे आगे नहीं करना. इसके 6 स्टेजेस हो सकते हैं, हम 6 के 6 नहीं करने, हमें सिर्फ ये बनाने, ये 2 प्रोडक्ट बननी चाहिए. HCl बन चुकी है, C2H5Cl बन चुका है. देन टर्मिनेशन. अब टर्मिनेशन में भी कोई यहाँ पर उसने स्टिक नहीं किया, मेरे ख्याल से स्टिक किया है, या उसने स्टिक किया है. कह रहा है each stage an indication of how butane can be produced as a minor product. तो वो क्या रहा है, ब्यूटेन बना के दिखा दें. सो ब्यूटेन बनाने के लिए you can use this C2H5 के जो रेडिकल है, अगर वो C2H5 के ही रेडिकल से मिल जाएगा, so we know that it will form butane, right बच्चों.
Yes, sir.
So this we already have been done, तो इस वजह से मैंने आपको करा दिया. अदरवाइज मैं एनर्जेटिक्स के पास पेपर्स आपको करा रहा हूँ, तो उसमें ये बनता नहीं था. ठीक है. So let's have some other questions of this.